All right, so for this lesson plan, I'm doing it over the first law of physics, Newton's first law of motion. Just going over the first one though, and with the grade of physics. And so I will be trying to show the whole lesson, but kind of doing bits and pieces of it along the way. And so, yeah, going into it. So good morning, class. We're going to be talking about first law of motion. This is Newton's work here, and we'll be seeing the physics part of it. Please take out your papers as we get into this because you'll be wanting to take notes on this. Just make sure you've gotten everything written down. So start off with, let's go over what that first law is, and that is an object at rest remains at rest as long as no net force acts on it. An object moving with constant velocity continues to move with the same speed in the same direction. So yes, this is a lot of words here, but let's break it up because to visualize this more and see what this is actually talking about. So say that you have this like a rubber ball, and you leave it on your table. At this point, it is remaining at rest since it's not moving, and it will continue to not move until something acts upon it. Like I hit it, and that's a net force in one direction, and I hit the ball and it rolls off the table. That is no longer at rest, and so that will follow it. That's still following the first law. However, if it's still moving on that table, possibly at this constant velocity, and remember we talked about this, so you guys can remember what constant velocity means, and it's going the same amount of speed over time, and so it's going the same speed, same direction, and it will continue to do so unless something stops it. It's like when you're in space, you could add a little bit of fuel and you'll just keep going and going and going and going. However, we live where there's friction, so a ball moving on the table will encounter friction that will stop it in its tracks, and then it might remain at rest until something else happens to it. And so that is basically the first law of motion. We'll continue going into different examples about it, and we'll watch a video so you can see other ways that this looks like. And so just make sure you've written down, write down this definition, also one in your own words. All right, so the first law of, his first law is also known as the law of inertia. And this is, this word inertia, make sure you've written this down too, and it's the tendency of an object to remain at rest or in the state of uniform motion. And you can kind of think of it, this is how I think of it at least, is that matter is lazy, and it will just want to keep doing what it wants to do unless something else changes that. And so I think about, like, if I'm in bed and I don't want to get up, I have a great amount of inertia since I want to remain at rest. I don't feel like getting up. But once I'm up, I will continue to do the things that I need to do. And so that's something that you can connect it to in your own lives. But yes, write this down. Again, we'll be going into a video in a second. And then for mass. Mass is the measure of the amount of matter, and I'm sure you've encountered this definition as well before. But also it's the measure of inertia, which is interesting there because if it has more mass, the larger something is, it's more difficult to move that object, and so it has more of a tendency to remain at rest. Also, if something is bigger and it's heavier and it weighs more, thus has more mass, it is more difficult to stop that thing when it's in motion. So say a car is in motion, it's a lot harder to stop that car with your own bare hands than a little rubber ball, which has a lot less mass. So that is why it's also the measure of inertia. And so let's go into more mathematical sides of things, and we'll be getting into more of that later as well, because that's we'll be looking at the first law in mathematical terms, and that's the whole point of today's lesson, is is that. And so for the first law of motion, you can basically add up forces to create this net force. Since this is, you see how there's no net force acts on it right there? Well, we are going to add up, you can add up forces to see what the net force will be on a certain object, see where it will happen. And so since we are talking about force, let's go into those units for it. Make sure you've written this down, this is very important. So the SI units, or the standard units for force, is newtons. As you can tell, Newton was the guy who put it into words. So N, capital N, and then it's 1 kilogram times meters over seconds squared. And so you might notice that meters over seconds squared is what we used for acceleration. And we just went over acceleration. So in fact, we'll get into this. This is more the second law. But you can see how kilograms is a measure for mass, and then meters over seconds squared is acceleration. So if you multiply the mass times acceleration, you get force. And we'll get into more of that later, next lesson, probably tomorrow. And so the first law, in mathematical terms, again, write this down. I want you to have this written down. This is very important, is that the sum of the forces, you know, we're adding up the forces. The sum of the forces, and this is what that little weird E is. It's basically saying the sum of, and so it's a faster way of writing that out. Sum of the forces equals 0. And so that's if there is no net force acting on it, as we said, it will remain in the state that it's already in. And so, you have it written down? Okay. So let's go on, and I'm going to go into a video with you guys, and so it'll go over what we've just talked about, and then we'll practice some things along with the video. And so let me get that pulled up here. I'm sorry, I should have had this pulled up beforehand. Okay.
You should already know what we mean by an object has a velocity, and what we mean when we say an object has uniform motion. If not, you may want to check out this video first. Try. What direction do you think the result?
Okay, so we would have watched through this video, but we're obviously not going to do that together here. But I just wanted to show you this little part where the students can try and find the resultant force, or at least the direction that I would be in. And so this is, I'll just show you the two examples here in this video.
Resultant force will be here. Pause the video and have...
So yeah, they give us this diagram. I would have it right, they would be writing it down, and they would be doing it along with the video here. And so you can see that if they got it correct, and we would see, they would discuss with their partners, and they would hopefully choose this way of doing it. And then, and it shows it there. So this would be the next, now try this, see here. So those are the two examples that they have in this video that they would be going over. And so they would move this arrow here, see it go shorter, and then it would go down this direction. And so this would be more of a harder question. We might have to talk about it a bit in class, but yeah, this will go along with the lecture. And so we'd wrap up that video. And then another thing that we would be doing, this is a thing, if it was an online class, then we would be doing it using whiteboard.fi. And basically I would have my own whiteboard, and they could have their students be accessing this whiteboard if we're on Zoom, and they could use your own whiteboard, and then I can see their whiteboards, and then they would be following along with me. But in class, in person, which is how I wrote this lesson plan, is that they would be in class in person. I would use the whiteboard online, in the front of the classroom, I mean. But yeah, so I'm running out of time here. I didn't realize I would take so much time, but I wrote out the first problem that we'd be going over together as a class, and then I'll go through the 5 steps with them of how to solve a physics problem, you know, with like sketching out the forces, which I had already done for them, and then isolating the object of interest, which is of course T1 and T2, choosing coordinate system, and that's like a really important step that we do together, especially get those angles in, resolve the forces in components, and which again we've kind of done since I solved it halfway just to make it easier for them. So this is the first sample problem that we're doing, and then we'd apply the Newton's first law to it after, yeah. So yeah, my time is up, and I would go through this, but yeah, it's over 10 minutes now. So that is my lesson plan.